What is going on, Diesel Nation? We're excited to have you guys with us for an episode with Cass from Choate Engineering talking to us about diesel cylinder heads. This has been an incredibly requested episode to have him on to tell us what he sees on core engines, what kind of upgrades can be done, things to look for, valve recession, just tons of different things. So we're really excited to have him on today. He's taking time out of his busy day to sit down and answer these questions, help educate us about diesel cylinder heads, whether you got a Cummins, Duramax, or Powerstroke. A lot of the information is going to transfer over. And one of the things that's going to probably come up is going to be tuning. And especially for the 6.7 Cummins guys out there, it's been a problem since these engines came out, is running a bit too much timing or dry pressure with a stock turbo, popping a head gasket. What do you do? How do you make sure when the head goes back onto the engine that it's done right and it holds? And we're going to get into that, but one of the most important things you can do before that happens is making sure you choose the right tuner. And we want to thank PPI for supporting the podcast. They have since day one, and the amount of testing that they do before they release tunes for a brand new platform or they're doing updates. They just don't, do tunes and then forget it, move on to the next one. They're constantly looking at updates and refinements and things like that. It can definitely save you a repair bill with needing a head gasket replacement and going through that whole process. So we encourage you guys to go to ppi.com, check them out, whether you have a Cummins or Duramax or Powerstroke, and check out what they have to offer, whether it's just a little bit more power for towing or it's a vehicle you're towing to the racetrack to go compete in something like UCC or Diesel Power Challenge. Those guys have it dialed in. And we also want to thank Diesel World Magazine as well. They are a sponsor of the podcast. I've personally been reading their magazine for many years, but anything that's going on in diesel, whether it's racing, products, builds, they cover it extremely quick, not just in the issues, but at dieselworldmag.com. So make sure you bookmark the page, check them out, and get the latest and greatest in diesel. All right, we're going to get to the podcast with Cass and drill him with questions about diesel cylinder heads.
This is Corey Willis with PPI, and you're listening to the Diesel Podcast.
I'm Adam Blattenberg from Diesel World.
This is Dan, owner of Dan's Diesel Performance.
I'm Cass from Diesel Doctor of Tennessee, and you're listening to the Diesel Podcast.
Cass, it is fantastic to have you back on the Diesel Podcast. You've built quite the fan base with your episodes, and I know today's topic is one I've seen pop up on YouTube, on Instagram, direct messages, and that's going to be cylinder head talk. So we're looking forward to having you on and picking your brain, so to speak, and learning more about them.
It's slim pickings, but I really appreciate you having us, and it's always a pleasure to talk diesel stuff. So we enjoy it.
I think one of the main things that, I'm sure you guys come across it a lot building engines, but that I've heard from enthusiasts and even myself, whenever I've thought of, doing an engine build is, okay, why should I do anything to the head? Is it worth it? Is it worth the extra cost? What is the weak point with the factory setup? Are there weak points? How can I improve it? And there's so many questions around that I think this topic's really going to help the guys out there that are either getting ready for race season or their truck's down or they need to get an engine and are getting ready to call you guys, and they can start thinking about the cylinder head. So I wanted to just kind of turn it over to you and get your perspective. You see hundreds or thousands of them a year. What are some things that people need to ask or know about cylinder heads on their diesel engine?
Well, yeah, that's a great question. I mean, you and I had spoken before about what topic to kind of get into on this, and I think as we progress, as we continue to do more podcasts, I'd kind of like to center around maybe just kind of a series because there's so much information that can be said about cylinder heads, valve train assembly, things like that. That it encompasses a whole lot. So today, I think the best thing we can do is just kind of take an aerial view of cylinder heads and what guys might be interested in some of the questions that I get asked a lot, and some things to consider when you're doing an engine build, how to upgrade. I guess, besides selling a lot of long block engines, we often get questions about short blocks. Not only short blocks, but, guys that are pulling their heads off a blown head gasket or whatever reason they have the cylinder head pulled off. There's some things to consider about that, and I guess I'll just kind of start at the base and work my way up. most of the time, guys will pull a cylinder head off an engine, and they'll think, okay, well, what I need to do is, at the bare minimum, a lot of guys will pull the head off, and they'll never have it. For instance, a 6-liter or 6.4, they won't have it surfaced. They'll just put it right back on. And when I say I'm starting from the ground up, what I mean is if I'm looking at the cylinder head, we're just kind of look at it that way. We're looking at the mating surface as it sits on the block. We'll start from there and kind of work our way up, all the way up to the keeper. Okay. Obviously, the first thing asked is it really that important to finish the cylinder head to have it machined flat? Of course, we all know two mating surfaces that are not flat will never seal correctly. And typically, the guy's he's on board with that. A lot of times, what will happen though is he'll figure that the only thing he really needs to do, because the truck was running before, I didn't have any issues. What I need to do is just go ahead and surface it and stick it right back on. And I'm starting to see more and more posts and different things and questions that are asked, and you'll wind up having a guy that will just take it to the machine shop. Now, again, in our area, for certain, there's a shortage of good machine shops, and we talk about that a lot. But what is a big no-no, and unless you are there to know what to ask, sometimes you get shortchanged and you don't know any better. You just think, they're the doctor. You go to the hospital, you think, okay, whatever they say goes. They're experts. They know exactly what they're doing. And a lot of times you find out, in more cases than not, they'll kill you if you're not careful. You just make sure that you are watching with both eyes. And the machine shop's no different. In my mind, it was always, well, the machine shop, that's a place of, tight tolerances and accuracy and things like that. But there's a huge, and that's true. But there is, it's amazing to see how much actually gets out of the shop these days. And we see the evidence of it. And the reason why I say that we see the evidence of it is a lot of times we'll have cylinders, we'll have pistons that come in after we pulled the heads off of an engine for teardown. And the first thing we'll see is the valve that came in contact with the piston. And typically what happened on that, there's multiple reasons for that. We'll try to get into the reasons for it. But a lot of times what happens is the guy has the head surfaced, but what he doesn't realize is that changes what's called valve recession. And what that is basically how far the face of the valve, would sit down, the difference between the surface of the head and the face of the valve, that depth right there. If you were to look at something like a 6.0 or 6.4, somewhere between 13 and 27 thousandths recession, which doesn't sound like a whole lot. And it's really not a whole lot when you compare it to a Cummins engine or something like that. But it's extremely important. If it's not kept within the correct tolerances, you wind up having piston to valve contact. And what happens is it just, not only does it damage the valve, but it also can damage a lifter. It can bend a push rod. It can wreak havoc. And the main thing to note is if you're taking that head off and sending it out to the machine shop, a lot of times what we find is because these are hardened seats. A lot of guys, a lot of machine shops, I know this personally. I'm just kind of giving you the benefit of my experience before I had gotten into the machining side of things. They use stones, and instead of being able to take off much material with that stone, they're just basically polishing that seat itself. The problem with it is when you go and you take 6, 7, 8 thousandths sometimes off the top of the head to make it flat again, and you put the valve back in and you stone the seat, it doesn't remove enough material from that seat to cause the recession to be at the right height. And they put that head back on, and then the next thing they know, they just hate this truck that they've got because it's nothing but a nightmare. And they created their own nightmare. So that all being said, it's extremely important, not just when you're building an engine, but anytime you have the cylinder heads off. Another thing to consider about while you have that time to have the cylinder heads off, it's not just a matter of cutting new seats and what we do, and I'll kind of get into more of this, we take advantage of, if the cylinder head's off and we rework a cylinder head for an engine that we build, is we'll cut, like on a Cummins did this, everybody but the Duramax actually did this because Duramax is aluminum head. They used a integrated seat into the head, which means when they were casting this head, machining this head, basically what they did was they just cut a pocket or a seat into the head itself. It is the same parent metal. Okay, the seat and the head are the exact same. There's not two different metals. The problem again that we see with that is a lot of guys talk about 6.0, 6.4, 7.3. Different heads crack, Cummins heads cracking. A lot of issues there with Cummins heads cracking, and the reason for that is because 75 to 80% of the heat that's within the valve itself is emitted through its seat. Okay, so you have a tremendous amount of heat that's trying to be taken away from the valve itself. But when you have the same parent metal, that heat dissipation rate is not as great as what it would if you had something like an induction hardened seat. Plus, the induction hardened seat holds up a whole lot better because it is a hardened seat over a period of time. So anytime that we do an engine, we put a long block in a customer's truck or whatever, we always take, and it is quite a time-consuming process to be able to cut all the seats out, set the right pocket height, press in a new seat, cut the new seats, and it's extremely important though. So if you have the cylinder head out, or off your engine, it's a great time to take, to redeem that time wisely and be able to install these induction hardened seats. Some other things though that guys, the shortcuts, I guess, is what I'm trying to, kind of narrow down here. Some things that I see as an industry standard. What a lot of guys do, and I have people call me, and there's a huge misunderstanding of valve guides in the diesel industry. And, some guys, I'm sure I'll get jumped on for saying this, but it's extremely, it's proven, okay? A lot of guys don't know any better, and they'll call me and they'll say, hey, I want a bronze guide put in my cylinder head. Can you do that? Do y'all install that? And they think of it as some sort of upgrade. But the problem with it is, while on a gasoline engine and for certain applications, that is a liner would be a better choice. In a diesel application that's a daily driver, it's not. And the reason for that is that other 25% or 20% of that heat is actually dissipated through the guide itself. And what winds up happening is that the cast guide is a cast guide has graphite in it, okay? And the graphite is great for lubricating. For soft lubrication of soft materials, it works fantastic for that. Plus, it has a better abrasive properties than what the bronze liner does. Typically, what guys do, and the reason why they use those bronze liners, is because it's much easier to fix the cylinder head that way. It's not because it's the right way. It's just a lot cheaper. It's a lot faster. It's a lot less headache. So what they do is they basically they drill and ream the center of the guide out, and then they will drive a liner in, and then they'll use a ball and swedge that liner down inside. It doesn't provide a long-lasting fix. It's a short-changed area. So everything that we do, and again, most of the cylinder heads that you see aren't drive-in guides from the factory. They'll generally machine that part directly into the cylinder head. What we'll do is we'll core drill ream all the guides, and then we'll press a new cast guide in, and they hold up a whole lot better. It's better than any alternative that you'll find for that. So those are just some things to kind of keep in mind while the cylinder head's off. Because I mean, good night. How many guys, 6.7 Cummins blown head gaskets that we're seeing? We see a lot of that. A lot of heads being pulled off. 6.0s. How many times? If you don't buy an engine, it's almost nowadays with a variable geometry turbo, it's almost a given that even if you don't ever have to replace your engine, at some point in time, especially if you're looking at power adders or anything like that, the head gaskets are definitely predominant failure issues. So it's a good time to do that.
I know with the 6.7 Cummins crowd, it's it's something that's been around since they started, with the engine, especially when you add tuning and other sorts of things, is it does find that weak point in head issues. And the question that's out there seems to be kind of what you mentioned, like, hey, send it to a machine shop, get it resurfaced, put it back on. But it's not that simple. And I think asking these kind of questions about what should I do if I have a head gasket failure, or you're getting a long block or a short block, or those sorts of things can save so much money, and then also help with the performance or longevity of that setup.
For sure. Yeah, and there's a lot more that goes, and I just blew through that whole general, just basically overview. But there's things to note that guys really don't, without knowing, the ins and outs of something. You just really have to. You're at the mercy of the guy telling you whatever it is that he's telling you. There's really a lot of a premature valve failure that happens. And the causes of, valve failure can go anything from, contact stress, temperature, contamination that we talked a little bit, and I want to get into that on a certain episode maybe, of contamination. We talked about sulfur, vanadium pentoxide, sulfur contamination, different things like that. But I guess the number one reason that I see valve failure or premature valve failure, a lot of times it just happens to be the guy that did the valve job beforehand. Again, going back to what we were talking about, the heat dissipation, some things that are extremely important is valve face and valve seat contact. When you're looking at a cylinder head and you're cutting a seat, and I know that this is probably getting more in-depth than what most of the listeners are maybe interested in, but this kind of gives you some idea of the accuracy that needs to be involved with doing a proper cylinder head job. Concentricity is a term that you hear thrown around a lot when you're talking about valve face, valve seats. And you basically got a concentricity of the seat of about 1/1000th of an inch. If you kind of, like I said, if you kind of keep that in mind, what is 1/1000th? Well, the human hair is 3/1000th of an inch. So that it's very minimal. What that means is that seat needs to be concentric to the valve face within 1/1000th. It needs to be, as it opens and closes, it needs to be able to come back to the same point. And that seat needs to be cut so that it is in a perfect circle. It doesn't need to be eccentric or off-center. And if the valve seat itself isn't cut properly, there's a lot of dimensions and a lot of tolerances that are given. A valve seat angle, everybody has heard about a 3-angle valve job. Basically, what is that? A 5-angle valve job. You've got a top cut, a throat cut, and a seat cut on a 3-angle valve job. But what you're looking for is proper sealing where the valve itself comes in contact with the seat, and there is a width that needs to be correct. So if you have too broad of a width, then what happens is you lose contact pressure. The valve itself does not seal as well as it should. Plus, it opens itself up for other failures down the road. If it's too thin, typically you'll see somewhere in the range of 50, 60 thousandths for a seat width. But if it's too thin, what happens is you don't have good heat dissipation. If you have a lot of overhang where it comes in contact, then you can cause premature wear on the valve. It can develop a hot spot on the overhang and burn and cause a valve to basically just come apart. It looks like a blowtorch. Sometimes you'll see some of them taken apart, and it looks like that there's it looks like somebody took a cutting torch on the valve and just cut a chunk out of it. And that's caused from something not allowing that seat to completely, it causes the valve not to seal against the seat. And that dissipation that we keep talking about doesn't take place. And so it causes the valve to fail prematurely. So there's a lot more that goes into proper cylinder head job than what a lot of guys think. Just pulling one off, resurface it, slap it back on. These are all things that are extremely important. And you're doing all this because you don't ever want to do it again. You want something to be one and done. And in order to do that, that's something that we do a lot of. We have a lot of guys send us cylinder heads. We've got shops that will send us, pallets of cylinder heads, and we'll, rework the cylinder heads for them and then ship them back to them because they don't have a good shop in their area that might be able to accommodate their needs for that. But it takes somebody that knows that particular cylinder head, because all those dimensions that we're talking about, all those tolerances that we're talking about are specific to that particular head. Whether it's Ford, Chevrolet, Dodge, Big Block, Chevrolet, doesn't matter what it is, they're all specific to that certain one. And so you really need somebody that knows that engine or that cylinder head, or if not, has access to the tolerances and will make sure that they are what they need to be when they leave. A lot of guys will, there's certain things that too, guys talk about camshafts. We were talking about that I think on the last episode about lifter failure. And going back from the lifter failure, seat velocity, we touched a little bit on that. And, guys are always talking about upgraded valve springs and when to upgrade a valve spring. And what that does to the valve train is that increases the stress of the valve itself, the tensile strength of the valve. You're pulling much, much harder. It's 15 to 45,000 psi is what you basically are seeing against the face of that valve as it's being pulled up between combustion pressures and, of course, spring pressure. So there's sometimes people think by upgrading certain things, it's like any other thing that you see in a truck. You see a guy that comes out and he buys a tuner, and he thinks that's great. This is what's my next step. And the joke in the industry, and which is really true, is the first 100 horsepower is cheap. It's the second 100 horsepower that gets you, because that's typically where you really start breaking stuff. Not always, but for sure, you'll generally find transmission issues or things like that, drivetrain issues. And the same thing happens. The guy goes, "Oh man, I need to just upgrade my valve spring." And that's fine, they can do that, but what they need to know is, are they matching the right valve with the right spring? If you're going to do that, then you certainly want to use the proper valve that has a correct tensile strength to withstand whatever pressure you're doing, and that again goes back to the cam, seat velocities. There's a lot more things that enter into, let's just throw this on this and see, because it's like an equation. Whatever you do to one side, you have to do to the other. Well, for every action, there's an equal and opposite reaction. It's that way. And the more I'm in this business, the more I realize, one thing affects the other. You can't hardly do just one thing without affecting, especially internally, without affecting there being a adverse or inverse reaction to it. So there's a lot to consider.
That's really strikes at, I think, the heart of the diesel performance, and it probably extends to other types of engines, but it's like, you're at a show or at a race or hanging out with your friends, and one of them's like, "Oh yeah, I got the stage 2 head on my truck," and you're like, "Well, what's a stage 2?" "Well, I don't know, it's a stage 2 or stage 3 or stage 1 or stage 3.5." Mm-hmm. And it's because it's, I think, such a complex thing. There's so much involved in the cylinder head or heads that for those of us that don't do it for a living, that don't know all that information, it's like, okay, well, stage 2 is better than stage 1, stage 3 is better than stage 2, but what does it really mean?
Exactly. Right, exactly. And for some applications, the stage 1 may be a better choice than the stage 2, and vice versa. Mm-hmm. But you really need an engine builder that is familiar with the components that you're putting on your truck, because that's what's acting on what's internal. When you have something like a single valve with a large diameter, you have more more contact area, more surface area on the backside of that valve. So it becomes more important of spring pressure and increasing the spring pressure in order for the turbocharger that you're putting on that truck to keep it from floating that valve. And when we talk about floating the valve, is when you're talking about putting a lot larger boost pressure, you're looking at that valve now. It's just like a transmission might. A guy might look at a transmission or anything hydraulic. Hydraulics and fluids and airflow are all in some way kind of synonymous because they work off the same principles. But a larger valve will render more surface pressure against it. Same thing with a valve. When you have a large diameter like a 7.3 head or something like that, you got to put a turbocharger on a 7.3 on the intake side. The seat pressure now becomes an area of of more importance now because you're trying to force that valve open because you have a very large diameter head, whereas a cylinder head that utilizes a couple of valves per cylinder head, like a Powerstroke or a Duramax or a Cummins, it's a 24 valve. It now has a smaller diameter on the back side of that head, so it does not have the same amount of force that's acting on it. So it's not. There's certain areas that are more important to increase spring pressure. Now that's all relative to the turbocharger that you're actually using, the boost pressure that you're using, and there's other things to consider too. First off, you're going to have greater drive pressures when you're looking at a variable geometry turbo than you will with a non-VGT turbo. Your drive pressures are always going to be increased because you have a restriction now in that exhaust. So then you start looking at floating valves. So when you have a large VGT setup versus something, and then that goes back to AR housings, that all has effect of how big that housing is on the turbocharger as to what your seat pressure needs to be. So there's a lot that enters into this equation. It's not just, hey, I think you need a stage 2 head or a stage 1 head. Now, don't get me wrong, it's not so many layers that you can overcompensate in spring pressure and still achieve everything that you need to do in certain applications. But there is a line that goes that you go between. You say, I'm stepping up to this setup. Now what do I need to do? And will this setup for this type truck work the same as a 12 valve versus a 24 valve? No, they're completely different. When you're looking at cylinder heads, when you're looking at do I need to upgrade this or that? So it's a lot more to consider. So you really need somebody that knows their stuff that can work with you to make sure that you're getting the proper setup.
That is the toughest part, because I was just thinking while you were going through those steps, like there's probably a certain set of upgrades that probably encompasses a lot of the trucks that are out there. Say like in a work application, maybe a little bit more power. But then once, and it seems to be what we all do with diesel trucks, is we'll want to modify. So we're going to get into different turbo setups. We're going to get into compound singles, different AR housings, different types of things. And it's like, okay, now we've taken, probably, these general set of upgrades that would be fantastic. And now there's a whole other set of questions that I don't even know to ask. But the thing is, like, I want to make sure that when I'm selecting this engine builder, this company to build the heads, like they're 5 steps ahead of me. They're asking me the questions so that it can all fit together. And I think that's really what this episode is definitely about. Is it's not necessarily just picking the most expensive upgrade that's out there. Right. And it's not just saying, I'm going to get by just doing this and I'll be okay. There's a lot of pitfalls along the way.
Absolutely. Yeah, and that's the reason why most people's, if you're like me, you go into Best Buy or something like that, and your VCR still, back in the day, it still blinks 12 o'clock because it's got all these options now, and you really don't know what to do with it. You just really needed it to do with one thing. Well, it wasn't the best for the application, right? You just wanted it to do this thing, but you bought the best because it had the bigger price tag on it. That may have been, that was the choice. If I can afford it and I can swing it, that must be the best. And it is very selective. The stuff that we do, especially, there's a lot of things to consider. The same setup for a supercharger doesn't work for a turbocharger. The same camshaft for a supercharger doesn't work for a turbocharger. There's an amount of overlap. There's a lot of things that really enter in. And without getting too deep into that, because there's a lot of mathematics that are involved with that. And there's some really great resources that I have in this industry that, when I get stumped on something that's new that we're coming across that we're trying to do, that that we might not necessarily have the experience in that area, that we haven't tried that setup before. Sometimes you can save yourself a lot of headache and a lot of grief by sitting down and just saying, hey, let's kind of do the math. Let's run over and see how this works on paper before we try to actually put it on the truck and spend money, because you see so many times guys that will buy setups for fuel and air, and I can't tell you how many times I see this on Facebook or on Instagram or whatever, somebody's advertising. I decided to go a different route. I don't know if you ever noticed that or not.
Oh, yeah.
Like, I've got a set of these injectors and this turbo, and, I just decided to go a different route. It's only got 1,000 miles on it, And you think, well, wait a minute. Hang on, why you only got 1,000 miles on it? Why are you going a different route? Well, that application wasn't exactly what he really needed. And he probably would have been better off by speaking with somebody maybe that had a little bit more experience in that area. But, going back to the guy, though, that's doing the daily, and that encompasses, we're getting off into, extreme off-road or performance vehicles at that point. The guy that's maybe listening that's just really more interested in, I just need this truck that, I like to have my tuner on it. I like to have an extra 100 horse on this thing, and or whatever it might be. Or I'm just a guy running up and down the road for hot shotting. I just need to make sure that I got a good cylinder head for my truck. There's a lot that even goes into that, but we're talking about different things that we can do to upgrade the valves and the seats. And again, we talked about induction hardened seats and nitride hardened valves. Going back to the cause of valve seat wear, you have adhesive wear. There's basically when you have a bonding between two materials there's a transfer between them, but they're not of the same material. You start seeing what looks like, if you put it under a microscope on the valve seat, you start seeing something that looks basically kind of like a pitting, an erosion of that material, and it can be, there's a lot of things that can cause that: stress, lubrication. Somebody that maybe when you do a cylinder head, it's extremely important that the surface finish of the valve and the seat is correct. It's when you cut a seat, if there's a lot of chatter, and you can identify that pretty quickly by looking at if you've done it any amount of time. But if the surface finish between the two materials isn't correct, then you're never going to have a proper seat, and that's always going to lead to premature failure. And again, that's something that is, and I hate to be that guy, say that's best left to the professionals, but you really need to find the guy that is the professional on it, that's going to make sure that they do it right, that they really know what they're doing, because that's the only way you're going to have a long-term fix. But anyway, there's a lot more that goes on to that. But abrasive wear, there's spalling. There's a lot of things that you start looking at the valves and seeing the wear, and there's certain causes that are more prevalent now than what they used to be, and there's reasons for that. I know you and I had spoken a little bit about tribofilms on the valves and the seats and things like that. So basically, if you're listening and you don't know what tribofilm is, don't feel left out, because not many folks do. But as a thought, Patrick, somebody that you really do need to get on if you can, by any chance, get him on here and just do a podcast with him. A great guy to have would be Lakesby Jr., and he works driven on. The guy's a lubrication specialist, a tribologist, and he has just the brain of anything to do with friction and oil and the science behind friction wear analysis and things like that. The guy's absolutely. Anytime he speaks about something like that, my ears perk up. I'm going to go to whatever seminar he's at, because he's just that good at it. But basically, what tribofilm is it's when it's a material that forms between the two contacting areas, like your valve seat, your valve face. And what happens is the vaporization of the oil and the wear of the cylinder, or the piston, the rings and things like that. They kind of they make a layer after. It's a culmination of all these things taking place to make a layer against the valve face and valve seat, and it kind of acts as a cushion, and it helps to seal. And after the emissions that have taken place now, and the removal of phosphate and the removal of sulfur, we start seeing the tribofilm that used to be there. It's no longer doing the same job it once did, because the components of the oil and the fuel, that the unburnt fuel, it no longer provides that same protective layer. So a lot of guys ask me what type of oil they use, and I'll make a recommendation to them. But people don't really realize they'll come to me and say, well, my truck doesn't have any emissions on it. The problem with it is your truck does have emissions on it. And I know we kind of always touch base, kind of come back to this, but it's because it affects so many different areas. Most of the time, guys look at stuff like that and they go, well, which is also a good, I'm trying not to get too scattered, but it's, again, like I was telling you before, it's just such a broad topic that it's sometimes hard to follow a certain trail because I'll think of something. We were talking about emissions on vehicles. Nowadays, the cylinder heads don't last as long as what they once did because an EGR that's now putting this soot contamination on the backside of the valve, where do you think that's going every time the valve closes? Well, all that soot and that contamination that got on the backside of the valve from the hot gases being piped right back in, the valve closes, and now it's going to wear that guide like a piece of sandpaper. It goes in and out, and it continues to wear that guide. The valve gets looser because the valve guide clearance gets larger. Now your seat is it's not coming back to the same point at which it was. So you start seeing a valve, the head of the valve, in some cases, because the guide's worn so bad that it can actually break the head of the valve. So anyway, those are the effects that emissions have in some ways on the valve itself. So when a guy's pulling a cylinder head off and maybe he's got 100,000 miles on it, and he goes, well, I just need to have this thing surfaced and stuck right back on. But he doesn't consider to check the valve guides or the valve seat wear and do anything about that at the same time. He's really doing himself a major disservice, because if anybody has ever pulled the intake manifold on a truck that has an exhaust gas recirculation valve, they would be the first to tell you it's caked so bad in most cases that it's horrible. You can hardly, on a Cummins, you pull it out, you might have maybe a 3-inch slot that you can find air to go through, whereas you have this much larger plenum, but it's all coked up. It doesn't just magically go into the engine and poof, it's gone. It doesn't work that way. It just burns everything off. It makes deposits. It makes deposits on the back of the valve, like we talked about, and which, again, like I say, the valve guides on the engines that we see that are running exhaust gas EGR valves on them, we see a whole lot higher wear rate between them and maybe a pre-emissioned engine. That being said, going back to the whole tribofilm thing with the oils, that is also, you've got a lot of things now that are fighting your engine to not last as long as what it used to. Years ago, without all these emissions that were on them, the engines would take a lot more abuse. They didn't have to deal with this. They would last a lot longer because they didn't have to take the abuse that they do, today with the emissions. And these are things to consider. So when someone asks me about oils and what type of oil to use, it does affect a lot more. Most of the time, guys think, okay, oil's going to affect my main bearings, my rod bearings, my cam bearings, and some of the contacting surfaces, but they don't ever think about the vaporization of that oil and how it's going to affect the valve train itself. So there's a whole lot more to consider with that, and there's more reason now to run additives and things that will replace the things that were removed. There's more so reason to do it now than ever before because of the things that are having to be combated with the emissions that we're running. And like I say, a lot of guys are saying, well, my truck's not an emissioned engine. It was pre-emissioned. But the oil that you're running right now is an emissioned oil. And the fuel that you're running right now, the low sulfur fuel, is an emissioned fuel. If you look at it that way, then you can say every engine that's on the road right now currently is an emissioned engine, because basically that's the truth of the matter, and it is. So there's a whole lot more that goes into it, but that's kind of, like I said, that's a panoramic view of cylinder heads and some of the things that you have to overcome.
I'm glad you brought that up, because I was just thinking about the newer trucks and the challenges that they have with the EGRs and different things that are done with them. And my big question was, do the cylinder heads hold up as well, or don't they? I'm leaning towards they probably don't. So I'm glad you touched on that and talked about everything from oil and fuel and how that can all affect those engines, but also the older trucks too.
Absolutely. Yeah, I mean, a lot of the failures that you see, I mean, some of the Cummins, and maybe we'll get into that for the reasons for some of the 6.7s dropping exhaust valves. We've also there's been a lot of failures that we see. The 6.7 Cummins, the 6.7 Powerstrokes, both are having issue with the exhaust valves. They're dealing with a lot more nowadays than what they had to before. And all of it stems from the exhaust gas temperatures that they're dealing with because of the restrictions there that take place, because of, selective catalyst reduction systems and things like that are increasing the amount of temperature that they operate at. So wear rate is much more rapid when it's closer to those temperatures that they're operating at. But again, like I say, I guess if there's a takeaway from this, it would be if a cylinder head, and I don't want to put an exact number on something, because the guys, I'm sure I'll get, somebody that will say, well, my engine didn't have that problem, and don't get me wrong, there are circumstances for everything, and I totally get that. But as I go back, and I think that's a good example, if anybody's ever pulled an intake manifold off and looked at the carbon deposits that's inside that intake, just keep in mind that that's exactly what your valves are having to deal with. But when I say if I had a cylinder head that had been removed off of a 120,000-mile truck, I guarantee you, or a 100,000-mile truck, nowadays, I'd be looking at the valve guides every time. Every time that cylinder head's pulled off that truck, within reason, I would be wanting to check tolerances, because if it's having to deal with literal sandpaper against the valve guide, it's going to wear. It's going to wear a lot faster. And it's just because you pulled the thing off the engine doesn't mean that everything's happy. A lot of guys will call me and say, I've got an engine, a used engine I just bought. Everything looks good. And my question is how do you know? Well, I mean, it doesn't have any, there's no piston hanging out the side of the block. That's the standard of excellence there? No, it doesn't work that way. I can't see it. I was training somebody on something, this is a couple of weeks ago, and he said something. He said, I can feel it. I said, you can't feel it. Okay, he's talking about the valve guide clearance. I said, you cannot feel that. There's no possible way that you can feel a thousandth of an inch. I don't care who you are. I mean, if you're Superman, you might be able to. I said, we have spent a fortune on gauges. I like numbers. I'm a numbers guy. I like to know at the end of the build exactly what the tolerances were. I want to know, because you know what? 10 years from now, that guy may call me, and I'll be able to say, wait a minute, let me look back through my notes. Okay, this is what I had written down. This is what the tolerances were on that. But there is no possible way for you to look at that cylinder head and go, this one feels good. And I used to be that guy. I used to be the mechanic, that I got something from the machine shop I'll never forget. I had an engine, one of the first, way back when I started doing this, I was dealing with another machine shop, and we talked about cylinder finishing and surface finishes of the cylinder itself. And the guy had done a botched hone job on a Cummins engine. And anyways, it wound up wearing the cylinder rings out really, really fast, way faster than what they should have ever worn. And anyway, we were trying to figure out, why is this thing using oil on us? So, I mean, I'm pulling the valves out, and I'm kind of wiggling them. And don't get me wrong, you can flat tell if a valve is worn to a certain point. You'll feel, it will rattle around in the head, but you can't tell the difference between a thou clearance and a thou and a half clearance, or a thou clearance and a 2000s clearance. So that reason, I always tell folks, it's better just to at least have the shop pull the valves out, check the guide clearances, make sure that from the top to bottom, that the guide clearances are what they should be, because you've got way too much of an investment in at that point. So that's the reason why we do offer that service too. People, like I say, they send the cylinder heads. We do sell new heads. We have an exchange program too. So if anybody's listening and they have any questions about that, you can feel free to call the office and get in contact with us. If you're a shop, if they're shops and they're working, trying to find a good machine shop, we can ship heads and work on an exchange program that way too. Those were some of the things that when I was in that side of the business, I was really fighting. You've got to truck down, you got cylinder heads off of it. You need to turn around really quick. The machine shop is always the slowest process, it seems like, and it takes forever. They're generally backed up, and So we kind of have something worked out where we can get that turned around pretty quick for him now. So
that's exactly what I was going to say next. Is we've given, I think, the listeners a lot to think about, and there's a lot of things you would need to know about a truck or an application to be able to set them up with the correct, head for their truck and their build, and the best way to get in contact with you guys. Is it to call the shop, or is it better to send an email off, or which way is best for you guys?
Today there's a manifold of contact ways to contact a person nowadays. You can contact us through Facebook Messenger, or you can contact us by calling the shop at 901-553-9847 and get in touch with us that way. Or you can email us at office@diesel911.com. You can go on our website, and there's that diesel911.com, and click on that, and it'll provide you the email link to that. So any of those ways would be fine. I'm old-fashioned. I like to talk to somebody on the telephone, so I just that's my preferred choice. But we'd be glad to talk to whomever to get them set up and make sure that they're making the right choice with the right setup. Like I said, there's a lot of information that goes along with that, so be prepared to, depending on what you're doing, we just want to ask and make sure that we're getting you set up right. So, I need to know kind of what the guy's goals are. What's he going to do with the trade? Is it a daily driver? Is it something he's just taking to the track? Is it what kind of air fuel that we're looking at? What kind of camshaft possibly that he's looking at? There's a lot of things that we need to match up and make sure that to provide the absolute best solution for him.
I know the next question we're going to get, because you do have a fan club on the podcast. Every time we release an episode, they're like, ask Cass this, ask him that. So we'll definitely be watching YouTube and social media and things like that. But we'll have to see where this podcast takes the questions and what the listeners out there want to hear and everything. But cylinder heads have always, to me, it's just like pure magic that goes on in there, and I don't really know, but I know it's important. I just don't know what to ask. So hopefully, I think we did shed some light on it, some things to think about, and whether you're doing a whole engine or just upgrading the head or heads, the things to look for, things to ask, and then to reach out to you guys and have you guys answer their questions, and whether it's a shop or an individual, the programs that you guys have for exchange or upgrades, things like that's really cool.
Absolutely, yeah. And something I forgot to mention, we've got actually two different, we've got two different sides now to the business, and this is something that you and I had discussed previously. But we started out Diesel Doctor Tennessee, and of course they can contact us through that Facebook page, and that's more along the lines of a repair facility. But there's Choate Engineering Performance, which is dealing now with product development for diesel engines, Ford, Chevrolet, Dodge stuff, as well as the engine builds. So if you go on Facebook, you can look us up at Choate Engineering Performance or Diesel Doctor Tennessee. Either way, you can contact us that way.
Very cool. Well, I appreciate your time on this busy day and shedding some light on cylinder heads for us, and I can't wait to do the next one.
Absolutely, my pleasure. I enjoyed it, and definitely, if someone's listening, please put down a question for us, and we'll be glad. We'll do our best to answer it.
Don't forget, diesel fans, make sure and head on over to dieselworldmag.com, bookmark that page if you want to stay up to date on the latest in diesel performance, builds, and races. Those guys cover the country pretty much all year, every major event. So we go there all the time to stay on top of all the cool things that are happening and all the unique builds out there. And also go to ppi.com. They've got tons of upgrades, tunes, anything you want to do with your truck, they've got it. So we got an L5P, 6.7 Cummins, 6.7 Powerstroke, 5-liter Cummins and a Titan, the 3-liter Powerstroke. Those guys got the tuning dialed in, and they've been able to harness the power and the torque whether you have emissions on or whether it's a race vehicle. So no matter what you need, those guys got you covered. Till next time, keep the shiny side up.